Astronomers just pulled off something that shouldn't have been possible. They captured an image of a visitor from beyond our solar system at the exact moment it should have been invisible. We're talking about 3I Atlas, an interstellar comet that was just reobserved right after passing near the Sun, during one of the most challenging observing conditions imaginable. And what they saw has everyone talking. When any object in space moves into conjunction with the Sun from our perspective, it essentially vanishes. The Sun's overwhelming brightness drowns out everything nearby, making observation nearly impossible. Think of it like trying to spot a firefly next to a stadium floodlight. For weeks, sometimes months, these objects become ghosts, completely lost to our telescopes. But 3I Atlas didn't disappear. Somehow, observers managed to track this interstellar visitor through one of the most brutal observation windows in astronomy. The fact that they could see it at all means this comet is far more active than anyone expected. But to understand why that matters, you need to know just how rare these visitors actually are. Since humanity started seriously watching the skies, we've only confirmed 2 interstellar objects passing through our solar system. The first was Oumuamua in 2017, a strange, cigar-shaped object that sparked endless debate about what it actually was. The second was 2I Borisov in 2019, a comet that behaved more predictably. That's it, 2 confirmed visitors in all of recorded history. These objects move differently than anything bound to our Sun. Their trajectories are hyperbolic, meaning they're just passing through, never to return. They're not trapped by our star's gravity. They came from somewhere else entirely, ejected from distant star systems billions of miles away, drifting through the void until they happened to cross our path. If 3I Atlas gets confirmed as the 3rd interstellar object, it would be massive. But confirmation requires something specific. That's where the coma comes in. A coma is the cloud of gas and dust that forms around a comet's nucleus when it gets heated by the Sun. As the ice and frozen materials on the comet's surface warm up, they don't melt, they sublimate, turning directly from solid to gas. This creates that distinctive fuzzy halo around the core. The fact that 3I Atlas has a clearly visible coma tells us it's actively outgassing, which is exactly what 2I Borisov did. Oumuamua, on the other hand, showed no coma at all, which is part of why it remains so controversial. Some argued it wasn't a comet, but something else entirely. The presence of a coma on 3I Atlas gives scientists actual material to study, gases and particles that originated in another star system. Every molecule in that cloud is a clue about the chemistry of wherever this thing came from. And capturing it during solar conjunction? That required serious technological power. Observing anything near the Sun requires specialized equipment and perfect timing. Most telescopes can't handle it. The scattered sunlight alone would overwhelm standard sensors. And the narrow window between sunset and sunrise, when the object might be visible, is brutally short. Astronomers likely used advanced imaging techniques, possibly coronagraphs that block the Sun's direct light. Or they observed during twilight hours, when the Sun had just dipped below the horizon. But 3I Atlas remained faintly visible. They had to know exactly where to look, which means they'd been tracking its trajectory with extreme precision before it disappeared behind the Sun. One miscalculation, one cloudy night, and the opportunity would have been gone. The fact that they successfully reacquired it and saw the coma means months of preparation paid off, and what they're learning is rewriting assumptions. Interstellar comets are time capsules. They formed around other stars, in planetary systems we can barely imagine. The composition of 3I Atlas's coma could reveal whether distant star systems create comets with the same materials as ours, or if the chemistry out there is wildly different. Early data from 2I Borisov showed it was surprisingly similar to comets in our own solar system, which suggested that planet formation might follow similar rules across the galaxy. But every new visitor adds more data points. Scientists can analyze the light spectrum from the coma to identify specific molecules, things like water vapor, carbon monoxide, cyanide compounds. Each one tells a story about the temperature, composition, and history of the region where this comet was born. And 3I Atlas has been traveling for who knows how long. Millions of years, probably. Maybe tens of millions. It's been alone in the dark between stars until it stumbled into our neighborhood. That kind of journey should change an object, and scientists want to know how. If 3I Atlas is confirmed, it means interstellar objects might be far more common than we thought. 2 detections could be a fluke. 3 starts to look like a pattern. Researchers have theorized that billions of rogue comets and asteroids are wandering the galaxy, ejected from their home systems during planetary formation. Now, we're finally spotting them. Improved telescope networks and detection algorithms are pulling back the curtain on a population of objects we simply couldn't see before. This has huge implications. If interstellar visitors pass through regularly, future missions might be able to intercept them, send probes to actually touch and sample material from another star's domain. We wouldn't have to travel light years to study alien solar systems. We could wait for pieces of them to come to us. And as 3I Atlas moves away from the sun and becomes easier to observe, the race is on. There's still so much we don't know. How big is the nucleus hidden inside that coma? What's the exact composition of the outgassing? Is there anything unusual about its rotation or structure? And most importantly, can we definitively prove its interstellar origin by measuring its trajectory with enough precision? The object won't stick around forever. Interstellar visitors move fast, and once 3I Atlas swings past the sun and heads back out into deep space, our window closes. Telescopes around the world are likely pointed at it right now, gathering every photon they can before it fades from view. Every observation adds another piece to the puzzle, but time is the enemy. In a few months, maybe a year, it'll be too faint, too far, and we'll have missed our chance. Capturing 3I Atlas during solar conjunction wasn't just a technical achievement. It was a glimpse at something that came from unimaginable distances, survived a journey through the coldest, emptiest reaches of space, and happened to pass close enough for us to notice. We're living in the first era of human history where we can actually study visitors from other star systems, even if just for a brief moment. The coma glowing around this comet contains molecules that formed in a place we'll probably never reach, around a star we may never identify. And somehow, against all odds, we caught it. The real question isn't just what 3I Atlas is. It's what else is out there, silently passing through, waiting to be found.